All right, we're on to page 5, which is number 24. And 24 says 2 resistors are connected to a voltage source. You look at the picture and the resistors are in parallel, the 2 branches there. And at which position should an ammeter be placed? So they have, sorry, I didn't realize I was still in that awful pink color there. So you have, again, voltage source here. So you have V, you have a resistor, 3, 4, location 2 is right there. This was R1, this is R2, and they put 1 out here. All right, so where would you place an ammeter to measure the total current passing through only resistor 1? Well, 1 right here is bad. We've talked about this many times. This is not how you use an ammeter. This will cause the current to bypass this resistor right here and just go that way. So that'll cause a short. You don't want that. So 1 is wrong. 2 is going to measure the current not in R1. It's going to measure the current, if this wasn't here, through R2. So that's not it. 3 is the correct answer. It's placed appropriately and it's in the right location, meaning it's in the branch, so it's in the right location, and it's in series. What would be bad is if you went like this with A. That would be bad. That's how you measure voltage. And 4 is going to measure I total. So the answer to that is 3. 25, in the circuit below, what are the correct readings of voltmeters 1 and 2? This one has a 6 volt power supply, and has a 10 ohm resistor, and it has a 5 ohm resistor. And they're connected. And the voltmeters, this is number 2, V2, and this is V1. It's a parallel circuit. The voltage drop between here and here is 6. That's this number. The voltage drop between here and here is 6 volts. The voltage drop between here and here is 6 volts. So the answer is V1 equals V2 equals 6 volts. It's a parallel circuit. They all drop the same. If you want to know the currents, you would have to put ammeters like that, and you'd divide 6 volts by 10 ohms, and you'd get 0.6 amps. 6 volts divided by 5, and you'd get 1.2 amps. And if you want to know the total, you'd put an ammeter there, and you'd get 1.8 amps. But that's not what they're asking. Next question. 26. Which circuit diagram shows voltmeters V and A correctly positioned to measure the total potential difference? Total potential difference, in this case, I'm just going to show you the right answer and then tell you why. B is the right answer. If you look, there's one resistor, there's the other resistor. Their ammeter is placed here, and they put their voltmeter here. So that will measure the potential difference across this one and this resistor. The sum of those two, let's call it V1 and V2. V1 and V2 is just going to equal V total, which is what's over here. I don't know what it is, there's no numbers, but you should recognize that from this series circuit that that's how this works. So this is definitely appropriate. A is in series with everything, so it's used correctly, and because it's series, it's going to measure I total, which is going to be the same as I1 as I2. So that is correct. What's wrong, so that's answer B. What's wrong with A is the ammeter is used incorrectly. We don't put it across. We don't say, let's put an ammeter right there. That's not how it works. It has to be in line with it, just like this one is. So that's what's wrong there. In C, the voltmeter is in line with it. We would never put a voltmeter there. If we did that, it would measure the potential difference between this point and this point, which is pretty much always going to be 0 because they're at the same potential. There's no reason for the potential to drop. Potential drops because of resistors. So that's what's wrong there. And for D, it's the same thing. The voltmeter is placed incorrectly. All right, 27. Which diagram below correctly shows currents traveling near junction P in an electric circuit? So this is that Kirchhoff's rule, or Kirchhoff's if you like it. Node, junction, or current rule. The idea is the current in equals the current out. And in A, maybe I'll do that. I'll do A, B, C, and D. In A, the in is 4 plus 3. If you look at the picture, the arrows are going in. And 7's going in. Great. So we have 14 going in and none going out. That's not good. In B, you have 7 going in, and you have 3 and 4 going out. Hey, that's good. C, you have 4 and 7 going in, and you have 3 going out. I don't think that's true. And in D, you have 7 and 3 going in, and 4 going out. That is not true. The answer is B. All right, question number 28. Same thing, just a little bit different drawing. Again, is the I in equal to the I out? Yes, it is. This is conservation of charge. That's what Kirchhoff's junction rule is a statement of, conservation of charge. Because if what was coming in wasn't the same as coming out, that would mean we're creating or destroying charge, and you can't do that. So if I add up all the ins, I have 2 plus 3, that's it, going in. And out, I have 4 plus 1 plus 2, so 6, 7. So I have 7 coming out and 5 coming in, and one unknown A there has to be 2 more going in to make this be an equality. So the answer is B, 2 amps. 29. Going to try and finish this all in one video. 29, you have identical resistors are connected across the same 12-volt battery. Which circuit uses the greatest power? Again, a lot of power equations, but use the one that's most appropriate. In this case, I think I know what the voltage is in every one. I know the total voltage is 12 volts. So I'm pretty sure I want to use this equation because I have all the different configurations for R. In part A, it's 12 squared divided by, there's just a single R. In B, it's 12 squared divided by my R total. If you look at the picture, there's 4 1 R, just R resistors in parallel. So when you do the math, it's 1 over R plus 1 over R plus 1 over R plus 1 over R to the negative 1, which is 4 over R, or R to the 4th. R divided by 4. Which, when you do that, it's 12 squared times 4 divided by R. In C, there's just 2 in parallel, so instead of having these 2 on here, that would be 2 over R, or R over 2. So it's 12 squared R over 2, which is 12 squared times 2 over R. And D are 3 R's in series, so it's R plus R plus R, or 3R. So 12 squared divided by 3R. A question's asking which uses the greatest power. Well, this is 1, this is 4 times it, this is 2 times it, and this is 1/3 times it. The greatest one is the 4th. So the answer is B. And 30, potential drop of 50. So they tell you V is 50 volts across a 250 ohm resistor. What is the power developed in the resistor? I just did that equation. P is V squared over R. You do the math, I think you get 10 watts. 31, microwave operating at a voltage of 120 volts is used to heat a hot dog. It draws 12 amps, 12.5 amps, excuse me. That's I of current for 45 seconds. What is the power dissipated? In this case, we have I, we have V. Let's use that equation. Like I said, there's a whole bunch of equations, and feel free to have your reference table ready to look all these up. The answer is 120 times 12.5, which is 1.5 times 10 to the third watts, if you put it in scientific notation. So that's C. A couple more to go. 32, for which quantities are values needed to calculate the amount of energy? Energy in electricity is W. Power is W over T. So to get the energy, you have to do the power times the time. Bunch of different ways to find the power. Probably the first one that comes to mind is I times V times T. So if we knew the current, if we knew the voltage, and we knew the time, we could get the energy. So answer C says voltage, current drawn, and operation time. So I think the answer is C. 33, they tell you the current, this heater draws 10 amps. That's what I is. It has a resistance of 12 ohms. How much energy does it use in 60 seconds? Again, energy, or W, is just power times time. So in this case, which power equation do we want to use when we have those two? If you look it up, I think you'd see I squared R is the best one, times time. So 10 squared is 100 times 12 is 1200 times 60 seconds is 72,000 joules, right? Power is in watts. A watt is a joule per second times a second. So the answer is D. And our last question, 34, an electric iron operating with a voltage of 120 volts draws 10 amps. How much heat energy is delivered by the iron in 30 seconds? Really simple question. W is just P times T. The power is IV times T. I think 3, 6 is 1, 2, 3. How many zeros is there? 3 zeros. So 3.6 times 10 to the fourth when you do the math out, which is answer D. Thanks for listening. I hope this helps. Good luck on Thursday.